so for our even degree functions, you should have split them into subgroups where you had a positive leading coefficient and a negative leading coefficient. So that's what my plus and minus here is for. Okay, it's representing the leading coefficient. So for my even degree functions, when the leading coefficient is positive, what are the ends doing? What are the ends of the function doing? They're going up. Okay, they're going up, they're increasing, they're rising, whatever you want to call it there. But we're going to use this notation. We're going to say, we're going to talk about the left side. So as our x values are negative, the left side negative x values, our y values are going up, they're increasing, they're rising, they're going towards positive infinity. Y values are going up, positive infinity. For the right side is x approaches positive infinity. The y values are doing the same thing. Okay, so I like the use of the words increasing, rising, going up. That's good. That gives you that visual. But this is the mathematical, symbolic, whatever you want to call it, that they're going to use on the final exam. So you need to be familiar with this infinity step. If we have a negative leading coefficient for an even function, what are the ends doing? They're going down. They're decreasing. So the x part doesn't change. Okay, the x part doesn't change. We still talk about as x approaches negative infinity, the left side. When you see that, you should think, and let me write it above it, you should think left side. Okay, whenever you see x approaches negative infinity, you should think left side. When you see approaches positive infinity, you should think right side. Okay, our y values are going down. They're decreasing. They're headed towards negative infinity. And the same thing happens for the y values on the right side. Okay, so even, we've got the same behavior. Same end behavior. That's what this is called. End behavior. What are the ends of my functions doing? How are they behaving? Where are they going? Okay, what's the deal with the odd functions? They go in opposite directions. Opposite end behavior here. One end's going one way, one end's going the other way, and I can't spell behavior. Okay, so if we have a positive leading coefficient for our odd functions, the left side is doing what? Where is it headed? Positive or negative infinity? Look at the graph. Look at a graph of one of them. Positive leading coefficient for an odd function. What's the left side of the graph doing? It's decreasing. It's falling. It's going to negative infinity. Okay. Our right side, as x approaches positive infinity, the right side of our graph, the y values are increasing. It's doing the opposite. Okay, it's doing the opposite. Okay, and then that flip-flops if we have a negative leading coefficient. So as we go to negative infinity, our y values go to positive infinity. And as we go to positive infinity, our y values go to negative infinity. Now, I wanted you to write this down, and y'all are very engrossed in writing it down. But I don't want you to write this down for the purpose of memorizing it. Okay, I'm not expecting you to memorize these behaviors here, but you should be able to think through them. Okay? The reality is you always have your calculator at your disposal. But one day, if you take calculus, you kind of got to know this stuff without being able to look at the graph of a function. So let's think about it for a second. Okay, let's think about this for a second. Let's use an odd function, for example. Okay, let's use an odd function, for example. So we've got a positive x cubed. Okay, positive x cubed is our leading term there. As our x values are becoming really big negative numbers, okay, if I raise a really big negative number to the third power, what is the result in general terms going to be? A really big positive or negative number. Which one? If I raise a negative number to the third power, a negative. That's why the y values are approaching negative infinity. Because I'm raising a really big negative number to the third power. A negative times a negative times a negative is a negative. If I raise a really big positive number to the third power, the result's going to be positive. Okay? But if my leading coefficient is negative, I do the exponent first, and then I multiply by -1. So if I raise a negative number to the third power, the result is negative, but then I got to multiply by -1. That's why the y value is going to be positive on the left side, and vice versa on the right side. Okay? And then you can go through the same thing with the even functions. Okay? If I raise a really big negative number to an even power, say the fourth power, what's the result going to be? Positive, right? A negative number to an even power, negative times negative times negative times negative, 4 negatives is positive. Okay? That's why both of those are positive infinity. Then if we put that negative coefficient in front, I raise it to the power, it's positive, but then I got to multiply by -1, so that makes it negative. Okay, does that kind of make sense? If it doesn't, don't stress out about it. You can always look at the graph, but hopefully it makes some sense. Okay, let's look at another grouping. Okay, I want you to identify the number of x-intercepts for each function. I want you to make a conclusion relating the degree to the number of x-intercepts. This one might be a little tricky.